How do you rewrite a rational expression if you can't immediately recognize the common factors? We'll look at examples like 6x squared plus 18x plus 15 over x plus 3. In this lesson, you'll learn to rewrite rational expressions by seeing the expression as a division of the numerator by the denominator. So let's review. We've got a few rational numbers here. 5x over 6, 2 over 7, 2 over 7x. We want to think of each of those as the numerator divided by the denominator. And just because we have that unknown variable, that x, we can still look at it the same way. Remember, x is just standing in for a number, so we still want to think of it as 5x divided by 6 or 2 divided by 7x. So sometimes we don't immediately see the a times b over a times c form. And just because we don't immediately see it doesn't mean that we can't find it. That's when we really want to make sure that we think about our rational expressions in terms of the numerator divided by the denominator, and we can use division to help us find that a term. So a great example of this is 529 divided by 23. I want to look at this and see if I can find a common factor. Well, since I can't immediately find that common factor, I want to rewrite this as the numerator divided by the denominator, or 529 divided by 23. When I carry out that operation, I find that an equivalent form is 23 over 1, which I can also write as simply 23. Alright, so let's look at this example here with unknown variables. X to the fourth plus 4x cubed plus x minus 10 over x squared plus 3x minus 5. So I want to think, can I look at this and see a common factor? It's difficult, just like the example 529 over 23. But just like we did with that last example, we can find an equivalent form by using long division. So I'm going to go ahead and set that up. It's also important for us to remember that our denominator, x squared plus 3x minus 5, can equal 0. So again, like I talked about, I just want to set this up as a long division problem. And please take note that I did put in 0x squared as a placeholder, and that helps me to make sure that I'm doing my math correctly and I'm not skipping any steps. So the first thing I want to do is look at x squared and see how many times does x squared go into x to the fourth. I know that it goes in x squared times, so I'm going to write that up at the top. Then I distribute that x squared to my denominator. So just where we left off at the last slide, I'm distributing that x squared. That gives me x to the fourth plus 3x cubed minus 5x squared. When I subtract that, I get x cubed plus 5x squared plus x minus 10. Remember, I had to use that placeholder in order to get my x squared value. Next, I look to see how many times can x squared go into x cubed. Well, it's x times. So just like I did before, I'm going to go ahead and distribute that x to my entire denominator. And that gives me x cubed plus 3x squared minus 5x. I want to go ahead then and subtract those two things. And again, simply picking up where we left off. When I subtract those, I get 2x squared plus 6x minus 10. Then I want to think about how many times does x squared go into 2x squared. Well, if I multiply that by 2, then I get 2x squared. So I'm going to go ahead and distribute that to my entire denominator. When I subtract this, I get 0, which means that there is no remainder. And that tells me that x squared plus 3x minus 5 is actually my common factor here. And that's really helpful when we write it in an equivalent form. So here's the initial fraction that I had. And now, based on the long division that I did, I know I can rewrite it as x squared plus x plus 2 over 1, which I can also rewrite as x squared plus x plus 2. In this lesson, you learn to rewrite rational expressions by seeing the expression as division of the numerator by the denominator.